All right. My name is Gilles Arnaud. I am a director of photography, and I am part of a French association called CST, Association of Technicians, movie industry technician, obviously. And we are here to show you a study we made in the image department of this association. And this study, as the title says, is to see if the digital gel, which are now built in the LEDs, are as good is not the word, are faithful to the physical gel, let's put it that way. Nowadays, most of the LEDs, if not all of them, have digital gel built in. So it's a relevant question for the cinematographer and photographer to wonder if those gels are as good as the physical one. And so we decided to test that. I'm doing this presentation with Eric right here, who is going to present himself.
Hello everyone, my name is Chérioux. I'm the technical manager of the CST, and I'm also an ITC member. So.
Okay. We know that if a projector creates a slight dominant on a face, either a magenta or a green dominant on a face, it's easy to correct that dominant in post-production, in color correcting. That is why we decided to shoot simultaneously in the same shot two faces with different skin tones. You'll see the face later on. No, attends. And we decided to test two LEDs of different brands. I'm going to go over that later. We proceeded by comparison. We compared one LED equipped with a digital gel and with the same LED equipped with the equivalent digital gel. And we did the same thing for both LEDs, and we compared those two LEDs with an incandescent light, which we used as a reference. I'm going to to show you pictures of that later. For each one of those tests, we did photometric and colorimetric measurements, and for that we used the tools we usually used. I mean, DPs usually used on sets, whether it is a light meter or a color meter. Those tools are widely used by gaffer or cinematographers on the set. Now I'm going to show you the protocol we followed. So we did that in a small studio. This is a studio at the Panavision in Paris. Panavision rental place. This is a studio which is used for camera test or lighting test for films. Very simple set. As I said, we shot two faces with different skin tones, gray background, and color shot on the side. Okay? And the lighting setup was quite simple. We had the camera, we had the two actors and the two faces, and the light on the side. We had only one light, which was the light to test. Okay? And this light was always at the same position. So we never moved the light stand, and the same position and the same height. So we make sure that the light direction was always the same, okay? Even if we change the projectors. We had a gray background, as I explained, and we had a color shot. This was a very, very simple lighting setup, okay? The camera we used and the lens we used are here. So we used an Alexa Mini LF. You see here the settings we did in the camera. Of course, we shot in RAW. We shot at 3200K, and we used a Zeiss lens 65. Okay, this camera and this lens were and the camera setups and the lens were always the same for all the shots, meaning that the only thing that changed between shots were the lights or the gel. But the frame or the camera setups were always the same. Okay? Those are the three projectors we used. So we tested two LEDs, cream source, and sky panel. We decided to shoot LEDs which are widely used on shootings. And as a reference, we used a incandescent light. As I said earlier, we did all the stats at 3200K. Okay? So that's the projector we tested. Okay? And those are the 9 gels we tested. Okay? Obviously, we choose gels which are built-in, are digital gels inside both those LEDs. And as you can see, there are two types of gels here. There are color-correcting gels with the brown surroundings, and the color effect gels with the green lining. Okay, those gels have different effect. Okay, you know that, right? The color-correcting gels, as you know, the name says it, are to change the color correction or to correct the slight green or magenta dominant, and the color effect gel are to create a color effect, to create an effect. Okay. Here, what we are going to show you today are the result on two gels. One color correcting, the quarter blue, 203, and one color effect, the golden amber, 134. Okay? Oh, by the way, those references are Lee's references, as it said on the previous slide. Okay? Photometric measurements were made with this tool, which everybody knows, right? This is tools like 99% of the DPs use on sets, regular light meter. And the colorimetric measurements were made with that tool, a Gaussian. Not as widely used as the Seconic, but it's used anyway, and it's a pretty good tool too. Okay. Underneath, I wrote the four colorimetric measurements we've made with that tool, and as they come along, I'm going to explain them. But I imagine you already know them. Okay. All right. So, as I said, for each one of those gels, we did 5 shots. Okay. One shot was a reference. One shot was a sky panel with a physical gel. The sky panel with a digital gel. The vortex with a physical gel, and the vortex with a digital gel. Okay. That's what we did for each one of those gel. And of course, we started without gel. The first test we did is the 3 projectors without gel. So very important things here. I repeat, we set the 2 LEDs at 3200K on the menu of the LED itself. Okay? Doesn't mean that we did not make any measurement. We did, but we first set the LED and the menu of the LEDs themselves. Okay? All right. So, what are the measurements which are important here? The SPDs, the three spectral power distribution, which you have here. So what you can see on the left is the SPD of the incandescent, which is regular SPD of the incandescent, which everybody knows. And there you see the 2 SPDs of the vortex and the sky panel. Regular SPDs of LED with a slight spike on the red, and the hollow part on the cyan. That's typical of a LED. Nothing much to say about those SPDs. Okay, now let's go to the CCT, correlated color temp. As you can see, there is a slight difference between what we said on the LED and what the measurement says. The Gaussian says 3150K, and we set it at 3200. This is absolutely negligible. I mean, on a shooting, a DP won't bother about 50K. It's totally negligible. Same thing about the vortex. The incandescent is a little bit under 3200K. That also is no problem. It has to do with the aging of the lamp, probably. There is never an incandescent light which is at 3200. Most of the time, they are a little bit under because of the aging of the bulb. But once again, that has absolutely no consequence on the lighting itself. It doesn't show any dominant at that point. All right, let's talk about the DUV now. DUV, as you probably all know, measures the shift between the light and the black body path. In other words, it gives you either the green or the magenta dominant. If the DUV is positive, it's a green dominant. If the DUV is negative, it's a magenta dominant. And we can say, and it's safe to say, that above or under 0.002, it's absolutely negligible, okay? So here, there is absolutely no green or magenta dominant, okay? So those projectors don't create any dominant. The incandescent, it's normal because it should be on the black body path, so that's no dominant. And the vortex and the sky panel, the same thing. There is absolutely no dominant. TM30 is a matrix which measures the color fidelity. Okay, and there are two metrics, in fact: the fidelity index, which is the RF, and the saturation index, which is the RG. Okay. As you can see, for the incandescent, we are around 100 for each one of those measurements, which is absolutely normal. Incandescent being the reference, it's absolutely normal that the TM30 is at 100. You know. For both the LEDs, we see that the fidelity index is a little bit under, but still it's pretty good, because it's above 90. So fidelity index above 90 is absolutely totally acceptable. And for the saturation, it's a little above 100, meaning that it's a bit saturated, but it's no big deal. It's around 100, it's no big deal. So basically, we can say, just by looking at this slide, that those projectors without gels and used at 3200, we did not do the test at 5500, but used at 3200K are pretty good. Let's now, and that's, I'm going to give the mic to...
Okay, let's talk a few minutes about SSI. There's a lot of fidelity index. But why did we choose SSI for a project? There's a lot of reasons, but the first one, that the ability with SSI. Oh, that's better? Okay, thanks. The ability with SSI to make a comparison between two real light sources. With most of indexes, you can make a comparison between a real light and a black body or a daylight that's not real light. That's ideal, that's imaginary corpse. So for us, and especially for creative gel, we need to test to make a comparison with a reference, that's a tungsten incandescent, and with the digital and also physical light of our LEDs. So another reason is no observer. There's only a pure comparison of a spectral SPD. So that's, we can say it's only a similarity between two SPD. That's very good for us because we have no bias of the observers. We know when we use color rendering index or TLCI or TM30, we use a color matching function to simulate, to emulate the way we see things. And we do not want that. We just want to make a comparison between the two spectra. So there's no all good with SSI, of course. And then one thing missing. There's no graphic visualization. So, but 6 index alone is not sufficient for me. I decided to make a graphic representation to see the difference between the two curves. And what we see in blue is the difference, is that's the index. The more the difference are between the two curves, the lower will be the index. The index is 0 to 100, like all the color rendering index. Oh, that's a little bit loud. And as you can see, the SSI is also with a reference, and the reference is incandescent light, and with the LED that we want to test. Maybe?
No, I don't have much to say about this slide. The SSI are a little different from we see that both the LEDs are a little different from the incandescent, and the vortex is a bit closer than the sky panel. But there's nothing much to say about that. I have the feeling that, anyways, those two LEDs without gels are pretty good, as we saw with the previous slides. And now it's up to you.
Okay. Now let's take a look of what the camera records, because before it was only the measurement part. But what is really interesting is what the video files look like. For this project, we set up the timeline in ACs, Workflow Color Manage. And one thing is really important, there's no color grading, no color correction. That's only the IDT and the ODT that Harry log C3 and P3D65, because we make DCP. That's not the place to see a DCP, so that leads to what does it mean for us when you look at spectral locus. This is a chromaticity diagram, classic one, the 1941. That's not the best, but that's the one everybody knows. So I think that's a first step. And what we see here is a cluster in the middle. That's our picture. That's our two characters with the set. And of course, all the little spots of color are the color chart. So this is the incident. This is the incandescent, sorry. And this is the sky panel one. No gel. We see a little difference. The first thing is all the spots move to the spectral locus, to the curve. That means every color will be a little much more saturated. That changes the saturation. That's the one important point. Every time we use LEDs, color seems to be a little bit more saturated. Same thing with the vortex. The vortex is a little more saturated than the sky panel. And we see that we're close. We're very close for incandescent. That's no really difference. Maybe we can look, we can see a little more yellowish on the picture. See the difference? It's not so much with the vortex. It's a little bit lower. So the sky panel look a little bit warmer. Okay? So look at this picture with 3D color spaces. Because with a chromaticity diagram, there's no luminance. Oh, another one. There's no luminance, and luminance is really important too. So, or incandescent, same thing. Sky panel. You see, the brightness is a little different. But you can see too that the more you are close to the edge, the more you are saturated. The axis in the center is an achromatic line. So if you're in the middle, there's only black and white line, okay? And the more you are towards the edge, the more you are saturated, okay? And the U is a circle.
So that was for the three projectors without gel. Now let's see with the Quad CTB. So just I'm going to repeat myself, but you can see that for each shot, we did exactly the same frame. We kept the same focus, of course. We have the same lens, the camera setup, and also we tried to keep exactly the same f-stop. With the LEDs, it was easy. We could use the dimmer inside the f-stop, inside the LED. For the incandescent, obviously, it was a little bit more complicated, since we all know if I dim down an incandescent, I'm going to change the color temp, which of course I don't want to do here. So for the incandescent, either we used ND filters, gels, or we took out ND filters on the camera, or we changed the f-stop, but really never more than 1/3, maybe sometimes 2/3 of a stop, but really we did not change the stop much, okay? So for every shot, everything was exactly the same. The only thing that changed is either the light itself, or the gel, or to a much lesser extent, the f-stop, okay? So those are the 5 shots we did with each gel, okay? All right. Now we have 5 SPDs, okay? Obviously, once again, the SPD of the incandescent is different from the other one. That's fine. Let's look at the SPDs of the sky panel on the left. The sky panel physical gel on top and sky panel digital gel on bottom. We can see that both those SPDs are, they very much look alike, okay? Same thing with the SPD of the vortex. Both vortex physical gel and vortex digital gel, the SPDs look alike, which tells us that in that case, to answer the first question, do digital gel as good as physical gel? In that case, we can say yes. In that case, I'm talking about the Quad Blue with those 2 LEDs. I'm not talking about other gels or other projector, okay? Let's have a look now at the CCT. Remember, when we didn't have any gel, we said that the 3 CCTs were almost alike. We're very close to each other. The difference between CCTs was very negligible. Here, it's not the case anymore. If you look at the CCT of the incandescent with the Quad Blue and the CST of the Vortex digital gel with the quarter blue digital gel, you see that there is a difference of over 200K. And this begins to be noticeable, okay? So it means that the digital gel with the Vortex will have a tendency to look a little bit bluer than the physical gel with the incandescent, okay? So that's important. Now let's look at the TM30. TM30, same thing, okay? The TM30 of the incandescent is close to 100. Once again, it's normal. It's the reference, so that's fine. Everything is good. And the TM30 of both LEDs with both gels are pretty good too, whether at the fidelity index or the saturation index. In both cases, they are pretty good. And we can see that the saturation index in both cases are above 100. If we look at the Vortex especially, we got RG of 104 and RG on 103.9, and meaning that in both cases, the quarter blue will have a tendency to be a bit saturated, which, as we just saw with the without the gel, with the slide Eric showed you, it's something which, you know, with the LEDs, the color always have a tendency to be a little bit more saturated. Okay, now next slide. I'm sorry. Next slide. So SSI. So obviously we compare the four LEDs, both LEDs with both gel, physical and digital, with the incandescent. Okay. Here you can see that, you know, they are not. I mean, they are a little bit different from the incandescent, but it's not really, it's normal. It has to do, and especially the SSI, whether they are physical or digital gel, in both cases are very close to each other. You know, 73 for the sky panel and 83 and 84 for the Vortex. Okay, meaning that really, it's, you know, it's what we saw earlier with the SPDs. We can see it here. We did another SSI also. We did the SSI of the using in both cases the LED with the physical gel as a reference, and to test it against with the same LED with the digital gel. Okay, and so you see that for the sky panel on the left and for the Vortex on the right, and you see that in both cases the SSI is very close to 100, and that's really what we saw with the SPD. You know, in both cases the SPD of the digital and physical gel are very close. And once again, we can conclude from that slide that in case of the quarter blue with those LEDs, the difference between digital and physical gel is totally negligible. You can use either one, and that's fine. Okay. Once again.
Okay. Once again, is that consistent with what the video files say? Here we have incandescent, so same thing, and we see that all the cluster seems to look to turn to the blue. Okay, that's pretty normal because quarter blue is to give a bluish picture. Okay. So the difference with the sky panel, this is a physical gel. As you can see, there's a little difference, very subtle, between the digital and the physical. But as we can see in the SPD, that's very, very little. So we can say there's no real difference between physical and digital gel with color corrector gel. Our reference, the vortex. The vortex is a little bit cyanish, but that's quite the same. And we can even mix on the same set a vortex and a sky panel, and that will be very close and very easy to match the two lights. So we can say with quarter blue, that's quite the same. Why? Because it's only a difference in Kelvin. We only change a Kelvin on the black body. So that's not a real gap between the color, between the no gel. Oh. J'ai oublié qu'il y a la partie en 3D. And now, what it looks like with 3D LAB. As we can see, we have the same result with a little brightness. That's the same thing with the no gel, so no surprise. No reference. And the vortex. You can see a little brighter, a little more saturated as usual, and a little bit cyanish bluish. That's very close. So no real surprise. Everything is, the comparison is, that's quite the same.
Okay, now let's have a look at the other gel. For the golden amber, the CCT, the DUV, and the TM30 are totally irrelevant. Okay, this gel is not meant to change the color temp, so the CTT doesn't make any sense. It is not meant to correct a green or magenta dominant, so the DUV is not relevant either, and is not meant to measure a color rendering, a fidelity of color, since the gel itself creates its own color. So for all those gels actually, but we are going to talk only about the golden amber today. For the golden amber, only the SPDs and the SSIs are relevant. Okay. Okay. Let's talk about the SPDs. And already here, the SPDs gives us a lot of information. All right, let's go quickly about the incandescent, regular incandescent SPD. That's normal. Okay, what's much more interesting here is to compare the SPD of the sky panel first and then the vortex. Let's start with the sky panel. Sky panel with the physical gel and sky panel with the digital gel. You can see that the sky panel with the digital gel has a much narrower spike than the sky panel with the physical gel, meaning that the digital gel is probably going to be much more saturated than the physical gel, and the effect of the golden amber is going to show much more with the digital gel than with the physical gel. And we see just about the same thing with the vortex, although the spikes is a little bit wider on the vortex than on the sky panel, and meaning that there are going to be more colors towards the red. The saturation of the digital gel is more important than the saturation of the physical gel. And I must say, as when we were shooting those tested, we noticed that with our eyes, without even before taking any measurement or using the color meter or whatever. We could see that, with our eyes. Okay. The second remark we can make about that, which is also quite important, is that with the incandescent, there is a lot of infrared. Incandescent, usually, the red goes up, and then in the non-visible part of the spectrum, it keeps going up, and this is the infrared. So a lot of infrared. in all the gels, the LEDs, it drops down. And you can see even with the sky panel digital gel, there was no infrared at all. Okay, so it really drops down. And that really has a consequence on the underexposed red. The very dark red look a little bit more reddish with the incandescent than with the LEDs, because of this, because there are much more infrared in the incandescent light than with the other lights. Okay, so this is for the SPDs. Okay, now, all right. Here we have the SPD, the SSI. Remember the SSI of the quarter blue. The SSI of the quarter blue with the incandescent as test was not really, I mean, it was a little different, but no big deal. Here, really, it's very different. Really, it's very different. So in other words, you are going to have a totally different look if you decide to use, I mean, if you are using a LED with a golden amber and you know in your head, because you are used to it, how a golden amber looks with an incandescent, it's not going to be the same. It's not going to be the same. Especially with the, if you look at the sky panel with the digital gel, you got an SSI of 35, which is a lot of difference between the incandescent and the sky panel with the digital gel. And the vortex to the physical gel is the closest, 89. So we can say that the vortex to the physical gel is pretty close to the incandescent. But for the other one, it's really different. Just one very important remark here about the scale. Both the sky panel, both SPDs of the sky panel, they don't have the same scale on the vertical axis because of the spike. We had to use another scale for the bottom for the sky panel with the digital gel, but the SPD in both cases, the SPD of the incandescent is the same, although it doesn't look exactly the same with the. Do you see the? Yeah, you see the. Okay, you see this SPD here is the same as this SPD here, but it's just a question of scale. We had to change the scale. That's all. Okay, so this is a very important information, and this is another SSI using the LED with the physical gel in both cases as a reference, and to test the LED with the digital gel. And here you see a huge difference, okay? It's not at all the same, okay? As opposed to, remember the SSI with the quarter blue. Both SPDs were almost the same, so whether physical or digital gel, it was the same. Here, not at all, okay? You won't have the same color rendering if you're using the physical gel or if you're using a digital gel. Okay, it's not at all the same color rendering. Okay, this is not, and I insist on that. Okay, this is not a judgment of value of those projectors. Okay, this is a color effect gel. It's not a color temp gel. Color temp gel, you want it to be truthful because you are using a quarter blue or all blue or quarter orange, and you know what what it's supposed to do in terms of color temp, and you want it to work whether you use it on a LED or on a incandescent. In case of golden amber or any type of color effect gel, this is not the issue here. The issue is what your eyes see and whether you like it or not. You may like it. You may like very much the look of the digital golden amber with the sky panel. Okay, it's just a color effect. It has nothing to do with this gel is better than this one or what But keep in mind that it's different. Okay, if you're using a digital gel, you won't have the same effect as if you're using a physical gel, or if you're using an incandescent light with that gel, you won't have the same effect either. Okay, but that's all. Besides that, there is no. We don't have to judge that. Judge the DP who says, okay, this is good or this is not good for him. Okay, now.
Okay, just like Gilles say, it's not an index to say it's good or bad. It's a similarity index. I insist. That's creative effect. The only information is the both SPD are really different. So the effect is different. Is that the same thing with the video files? Yes, that's different. Incandescent, as we can see, there's a lot of information in the yellow, orange, and red. All the colors seem to shift and be more saturated. That's pretty normal. Okay. And now with the sky panel on physical gel. Look at the difference. Okay, there's a little difference in the green patch, as you can see. But not so close, a very little difference. Now, let's look at the digital. That's really different. And the things we see is the color seems to be cut, separate, and all the green patch seems to go towards 500 nanometers in the top of the curve. And all the red, orange, and yellow color seems to go towards to the line, to the purple line, okay? We see a real difference between two groups of colors. That's a really different effect. Now look at our two characters, look at the face and the frozen of the guy. Do you see the greenish on the frozen? Okay. Now, our incandescent and the vortex. Look at the frozen. It's quite the same. If we look at chromaticity diagram, look at physical, digital. Okay, physical, digital. That's the same thing. The way digital gel acts in the two LEDs is the same. Golden amber acts the same way. That's the same rendering color. And with physical, it's quite the same too. So, in conclusion, yes, I can show the same thing in 3D LAB. We can see the same thing. We have our golden amber on physical gel with incandescent and really close. Really close. A little bit saturate as usual. And now you see the difference. All the green parts seems to go towards the left and all the red part seems to go towards the right. That's separation between two colors. Our reference, same thing with the vortex. We're close, we're not. That's the same issue. We can see in 3D, 2D with luminance, that's the same thing. And we observe the same thing on the picture itself. We choose to make this kind of representation to show you exactly the thing, because that's not a DCP, that's not a film in a very classic way to watch a movie. So maybe it's good to have a representation of all the color move in space to understand exactly what you have in the picture. What's fun? You have the sky panel to the left and you have the vortex to the right. Both are digital gel. We can see they are really close. Really, really close. That's good news. If you want to mix two different models of two different brands in one set, that's a really good news. But if you want to have a classic incandescent look, maybe it's better to use a physical gel. They both will match also, but with a different look. We do not want to say that physical is better and digital is not. There's different creative intent, different creative rendering. So it's your choice. But we can say that what you see with LED is quite the same in most of time with most of brands and most of model.
And okay, this is the people who help us for this study. Okay, so if you have any question,